Today we're going to talk about the basics of quantum theory. Before we do that, I want to go through two laws. I want to talk about Coulomb's law first. Coulomb's law says that when you get particles together, their attraction to each other or their repulsion from each other depends on their charge, and it also depends on how close they are to each other. So if you have two particles that have the same charge, they want to repel. And the closer you get them together, the more they want to repel. If you have particles with opposite charges, they want to attract. And the closer you get them together, the more they want to attract. So if you have two protons, both have a positive charge, they want to get away from each other. And the closer they are together, the more they want to get away from each other. If you have a proton and an electron, they want to attract. And the closer they are together, the more they want to attract. So that's hard to explain the nucleus then. You've got this super compact, really dense area where you have a lot of protons. But this explains why the neutrons are in there. The neutrons help to separate the protons, so their repulsion force isn't as great. There's also something called the strong force going on in the nucleus too, which says that once you get those protons and neutrons really close to each other, there's a strong interaction that forms that helps to hold them together. And then Heisenberg's uncertainty principle says that you can never know the position and the velocity, how fast an electron is going at the same time. So if you know where the electron is, or at least close to where it is, you don't know how fast it's going. And if you know how fast it's going, you don't know exactly where it is. In this next section, we're going to talk about quantum theory. Quantum theory is a description of the atom based on wave properties and the probability of where you're likely to find an electron. So we can't pinpoint exactly where those electrons are, but we can say where they probably are at least 90% of the time. We're going to do this with quantum numbers. The quantum numbers are like an address for the electrons. There are 4 sets of numbers that tell you pretty close to where that electron is around the nucleus. Okay, I want you to copy down this table in your notes. We're going to have a quantum number. Notice we've got 4 of them. I just told you we had 4 of them. They are the principal quantum number, the angular momentum, magnetic quantum number, and spin. They all have symbols N, L, M, and S. And then the meaning is over here. So the principal quantum number, abbreviated with an N, which you've seen before. Remember, we had the N in the 2N squared. It's the same N here. It's the energy level, 1 through 7. That energy level also tells you how far away from the nucleus you are. So that first, remember we called this the N shells before. That N1 was the first shell you drew. And then N2, N3. So it's the same thing. It's energy level, and it also tells you distance from the nucleus. The angular momentum is abbreviated with an L. This tells you the shape of the electron cloud where the electron is. It's also called the sublevel. You have 4 sublevels, and I'll show you what these electron clouds look like in a little bit. The S is a spherical, the P is like an hourglass shape, and the D and the F are weird shapes. Magnetic quantum number tells you where exactly this cloud is in space. The P is the easiest one to think about. Well, I guess the S is the easiest one to think about because it can only be in one place. It's just a sphere. And then the P is the one that I'll ask you about on a test. It can be in 3 different spots. Think about math. You've got your x-axis and your y-axis. So you can have a hourglass electron cloud on the x-axis. You can have one on the y-axis. And then the z-axis would be the one coming out toward you. It's like the 3-dimensional axis. So you could have another hourglass shape on the z-axis. And the 4th quantum number is the spin, or S, and it's the spin of the electron, either up or down. Okay, so these sublevels again. or the angular momentum. They're SPD and F. SPD and F. You have one or more sublevels within an energy level. We'll get to those specifics later. And you can only have 2 electrons in one of these orbitals. So here are the shapes. Your S orbital is just a spherical orbital. Your P looks like this, kind of like an hourglass. Your D kind of looks like this clover shape. And then your F looks like this. All right, you need to get this table down too. We're focusing on sublevels here, and now we're adding in how many orbitals there are in each energy level and how many electrons there are in an orbital in that sublevel. Okay, so my S sublevel, I have 1 orbital. That S sublevel can only be in one place. So it just has 1 orbital in it. Because there's 1 orbital, each orbital can have 2 electrons in it. So you can only have 2 electrons in an S sublevel. Your P sublevel can have 3 orbitals in it. Remember, I told you you can have PX, PY, and PZ. Those 3. Since those are 3 separate orbitals, each orbital can have 2 electrons in it. So 2, 4, 6. You'll have 6 electrons in a P sublevel. The D, you just have to trust me here, has 5 orbitals, 5 different positions. Each of those can have 2 electrons in it. So 5 times 2 gives you 10 electrons in a D sublevel. And the F has 7 orbitals, 2 electrons in an orbital, gives you a total of 14 electrons in that F sublevel. So here, this final number tells you how many electrons there can be in the whole sublevel. So every S has a total of 2 electrons. All the P's orbitals together give you 6. All the D's give you 10, and all the F's give you 14.